Alright, this is lesson 8-6, exponential growth versus decay. Today's date is Thursday, February 13th, 2020. Our objective today is to distinguish between equations and graphs for exponential growth and decay, and then to also graph both of them by hand. So, here's your general formula. We've seen him before. Whenever we see f of t, we just think of that as y, or another word for y is the height. So I'll put in quotes here, the height. What about a? A, I think of my initial value. So this is my initial value. And then what we've been realizing slowly over time is on a graph, this a is going to be the y-intercept. And I'll put that in quotes too, because technically the y-intercept isn't just a, it's 0, comma, capital A. So that's the official y-intercept. But if you're looking where it intersects the y-axis, go to that coordinate on the y-axis and you're good. And then b, we've been calling this thing our factor. Factor, sometimes it's called the common ratio, but I like the word factor, it's used more often. And this is going to be thing that we need to remember here is what do we really multiply the heights by. So we'll write multiply heights. So how do you spell heights? Heights by this capital B. Cool, that's our analysis. We don't have to worry about what's happening in this exponent yet, not until later. Maybe even in Algebra 2, I haven't actually looked ahead. Let's talk about the difference between exponential growth versus exponential decay. So I'm just going to choose a random one. Let's just talk about growth first. So exponential growth is when, okay, so if I see an equation, how do I know it's growth? Well, whenever I have some value that doesn't have a t here, there's a t missing, so I can kind of ignore that a, and I'm only paying attention to this. So I'm really only paying attention to this capital B. Again, make sure you're looking for something that has a t or a variable, something in the exponent, and then that's the factor or the base that we really care about. And exponential growth is when b is greater than 1, and then vice versa, right? So decay is when that capital B is less than 1. And I'll make the note here also, and this is just me being formal, this is a good definition to memorize, but if you want to be very, very formal about it, I'll have to say that capital B has to be greater than 0 also. Obviously, if you're greater than 1, then you're greater than 0, so maybe you have to just apply it to this one. Capital B has to be greater than 0, because otherwise you'll have a negative factor and weird things happen. But yeah, for now we're always going to have positive factors. In fact, almost all through Algebra 2 that's going to happen as well. Alright, graphs. So we've seen this graph on the left over and over again. This is a graph of exponential growth. This table or the table with the graph over here on the right hand side is the other one, it's decay. Notice that both of them have the same type of curvy shape. One of them is a reflection over the y-axis of the other, which is kind of cool. The reason that happens, by the way, is because it's the same initial value of 3, and then it's just the reciprocal of the factor. So 2 is the same thing as 2 over 1. If you flip that, that becomes 1 over 2. So that's the reason that they look so similar. And I wanted to show you how similar they are in terms of their heights. So let's take a look at the 3. The 3 is our initial value, right? Or we want to think of this as kind of like our y-intercept, our starting point. And look right here, our starting point is 3. Our y-intercept is 0, 3. And that is the same exact thing for decay. Over here, when I have my start or initial value of 3, that's my y-intercept. It's the same on both graphs. What about this factor? So for this factor of 2, I have a height now of 3, and I multiply by 2 to get a height of 6, and then I multiply by, I kind of ran out of room, but I'll come up here, multiply by 2 to go from a height of 6 to a height of 12. I'm multiplying by 2 each time to get to the new height. And I should note here, I'm going left to right. So left going to the right when I think about multiplying by my scale factor. So don't go start on the right, don't go this direction. Always start on the left. So now that I have this function, I have my start value, and I want to go to the right. So if I go to the right, that means I'm going to multiply by a half. And you can see, I guess you can't really see, that this value should be 1/2. So let's go ahead and make a point here. If I go to the right, I had a height of 3. So I'm doing green now for this factor. If I had a height of 3, I multiply to get from here to here. I multiply by a half, or multiply by 0.5. But then Mr. says, no, what's going on this other side? So if you decide to do the opposite, if you decide to go to the left instead of to the right, I'll do this in a different color to let us know we're doing something a little bit different. Blue, I guess, because I can't really tell the difference between red and green. If I want to go from here, from this height right here, the height of 3 to the height of 6, what I'm really doing now is not multiplying by 1/2, but instead now dividing by 1/2. And if you remember your rules of fractions, whenever I have a divide by a fraction like 1/2, that's the same thing as keep it, change it, flip it. So it's the change it, flip it. Dividing by 1/2 is the same thing as multiplying by 2, which means I'm multiplying by 2 whenever I'm dividing by 1/2 to get from 3 to 6. And again, if I'm going left, I'm dividing by a half, and I'm going from 6 to 12. Okay, we'll talk about graphs a little bit more, but that's your intro now to growth and decay, graphing them. Let's talk about example 1. So we're going to be given an equation, a function, and we need to figure out if it's growth or decay, and we need to figure out what shape it looks like. So h of x, it's equal to 0.78 times 9/7, all of that to the power of x. Well, first of all, okay, I gave away too much already. Which of these numbers do I really care about when I'm talking about growth versus decay? And if you go back up to your notes, there it goes. It's the number that is beneath the exponent. So I have an exponent that has a variable. I have an exponent that's a variable right down here, which means I don't care about this 0.78. That's misleading. All I care about is 9/7 to the power of x. Okay, well then the next question is 9/7, is that guy bigger or less than 1? Because that's the main definition. Are you bigger or are you less than 1? If it's less than 1, decay, bigger than 1 is growth. And you probably have already answered this now, but it's bigger than 1 because the top is bigger than the bottom, and that's the general rule if you're ever stuck on fractions. So if the top in all caps is bigger than the bottom in tiny, okay, so that's going to be bigger than 1. If you have the vice versa, where the top is tiny and then the bottom is bigger, then that's going to be less than 1. So that's your hint for fractions. So that thing is bigger than 1, therefore it's growth. Okay, so that eliminates B and D. It has to be growth. Now, which of these is a function that looks like growth? Well, as I go from the left to the right, am I getting bigger or smaller? As I go left to the right, I'm getting smaller, so it's not A. As I go from the left to the right, I'm getting bigger, so the answer is C. All right, on to the back. Example number 2, graph the function and clearly label 2 points. Whoa. That fractions, what are happening here? This is a bunch of decimals. How are we going to do this? Generally speaking, and here's your, I guess, I didn't have room. I guess I could have put it up here. Maybe next year I can say, put the tip up here, Mr. Sindel. This is for me, not for you guys. I'll make my notes even better. But the general tip, I'll do it off to the side for everyone else, for you guys, is plug in x value is equal to 0 and plug in x value is equal to 1. Those are the easiest, generally. For all of today's lesson, it is 100% going to be the easiest. I cannot write easiest values to plug in. So essentially what you're doing is you're making a mini table of x and it's not really y values. If I think of that as y, then it's x and y values. It's really x and f of x values. And I'll plug in 0 and 1. So when I plug in 0, that should be my start condition, right? Because that's the y-intercept whenever x is 0, but let's show you why that is. So 2 to the power of 0 now. Anything to the power of 0 is 1, which means this is 1 times 3/4, and 3/4 times 1 is 3/4. So I'm going to come here and say 3/4. And we know that that is the decimal approximation of 0.75, not approximation, the exact representation. And what happens when I plug in 1? Well, that means it's going to be a 1 right here. 2 to the power of 1 is just 2, so this whole thing here is just 2. How do I do 2 times 3/4? Okay, let's do some scratch work off to the side. Or maybe down here. So if I have 3/4 and I want to multiply by 2, that's the same thing as 2 over 1. And whenever you multiply fractions, you just multiply the tops, multiply the bottoms. So multiply the top, 3 times 2, 6. Multiply the bottoms, 4 times 1, 4. Oh, okay, I can reduce that fraction a little bit. I can divide the top and bottom by 2 here, divide by 2, divide by 2, and that's going to give me 3/2. Oh, and I know the decimal, or not approximation, the decimal form of 3/2, that's 1.5. So I come back up here and say, oh, 1 is 1.5. Okay, well, now graph these, right? So an x coordinate of 0, y coordinate of 0.75, where's 0.75? So 0 means I don't move left or right and then go up 0.75. My first point is right here. And I could have done that just by looking at the equation, right? This equation says, hey, your start value, your initial value, your y-intercept is 3/4. And I'm like, oh, 3/4, that's 0.75, boom, done. And then the next step is to multiply this height by 2 to get from this height up to the next height, or maybe down to the next height, depending on if it's growth or decay. And multiplying 0.75, this 0.75 by 2 times 2 to get to this step, times 2 is 1.5. So I go over to 1. Notice I'm not going over to 0.25. I'm going over to the x value of 1, and I'm going up to the y coordinate, or the height of 1.5. So 1, 1.5. And those are the 2 points that you need. I could do this process again. I can say, okay, well, if I multiply this again and I want another coordinate, I'd multiply by 2. 1.5 times 2 is 3. And I can go to 2, 3, which is right here. But I don't need more than 2 points. On Khan Academy, graph 2 points, and generally speaking, the easiest are going to be x is equal to 0, x is equal to 1, and you'll get your 2 points that way. I'll make a note also, on Khan Academy, you'll have a bar like that's on the x-axis that you can drag up and down, but you will not ever need to do that for these functions. You'll only have to do that if you have a plus or a minus value. Like +1 means I'm going to move this bar and all of the heights of these points up 1. Or if it said -3, I'd move all of the heights of these points down 3 and move that bar also down 3. But again, we are not doing that yet, so please don't touch the bar on Khan Academy. You'll get the wrong answer. So I just want to be clear. I know I've repeated this a few times, but there's 2 ways of doing this. One is just doing a table, plugging in values. Plugged in 0, plugged in 1. The way that I recommend, and the way that I'm going to be doing first now on the second problem, is to look at your equation and see how it represents on the graph. So this is the y-coordinate. I can immediately graph 3/4 and then multiply by height of 2, or multiply by 2 every time I move 1 in the x direction. So if I move 1 in the x direction, multiply by whatever that factor is, and that's how to get your new height. Okay, so let's move down here to example 3. You should be able to do this one on your own, and if you're watching this video, you should be able to pause and try it. I highly recommend doing that. I know that it's hard to not, or like you just want to keep watching the video, but please stop the video and try this. So 9 is the y-intercept, my initial value. So I'm going to come up here to a height of 9, and boop, there's my first point. I'm halfway done. I have one of the 2 points. The next point, I'm going to have to multiply this height of 9 by 2/3, and I'm going to have to do some scratch work. I'm going to say, okay, what is 9 times 2/3? And 9 is the same thing as 9 over 1. I can show you I'm doing some work now. And whenever I multiply fractions, I multiply the tops. 9 times 2 is 18, and multiply the bottoms, 18 divided by 3. Or if you want to be really cool, what you could have done is you can say, oh, I know that 9 and 3, those will cross cancel. 9 and 3 cross cancel, and the 3 turns into 1, the 9 turns into a 3, and then 3 times 2 is 6. You can say, oh yeah, the answer is 6. Or you can say 18 divided by 3 is 6. Either way, you should know that the next height is 6. So coming down here, I say whenever I move 1 in the x direction, I'm going to go to our new height, 6. So I've moved to 1 and then come up to 6, and there are my 2 points. Done. I've solved the problem that quick. And that's what I'm hoping you guys should be able to do too. And if you're really, really cool, you can probably do this math in your head and say, oh, 9 2/3, cross cancel, 6. But yeah, we'll work on this more. More practice is better. You could continue doing this. You don't have to stop at 2 points. Maybe you don't want to graph your easy point. You're like, I want to make it difficult to myself. I don't want to find that point and another point over here. Okay, let's try 6, and then I'm going to multiply by 2/3 again to get the new height. Well, if I want to do that, 6 times 2/3, the 3 and the 6 are going to cross cancel. That's going to be left with a 2. 2 times 2 is 4, so our new height is going to be 4. You can come down here, so when I go another step in the x direction, only exactly 1, I'm going to come to a new height of 4, and there's my next point. The thing I haven't really talked about is, yes, we've graphed these points, but we haven't really approximated what they look like. So if I were really, truly doing this by hand, I would have to actually sketch this out roughly, approximately. But on Khan Academy, if you move 2 points, it'll automatically graph it digitally. But you should have some sort of line that goes really, really close to this x-axis out here, and comes up through these points like so. It goes out to the left forever and up and to the right forever. And same for this one. This is going to be decay. This is coming down through these points, and eventually, I don't know where it goes. I'm just kind of guessing now, somewhere out here, and it gets closer and closer to your x-axis again. So there is an actual curve that's going through there. We just kind of glossed over that. And just a reality check before we end the notes. 2/3, that is less than 1, so I have decay. Oh, that looks like a graph of decay. I'm going lower and lower and lower. And reality check, this is a power of 2. 2 is bigger than 1, so it should be exponential growth. And hey, it is getting bigger and bigger and bigger. Everything is matching up with what we know. Cool, so that concludes notes 8-6. I will see you guys tomorrow.